Can you hear me? If you can hear me, please give me a thumbs up. Can you hear me, guys? Yes. Okay, very good. Everybody, please turn on your camera. Today camera issue. From next class I will turn on. Okay, so from next class onwards your camera must be in working condition. Okay, please make sure that. Yes. Okay, so others, please turn on your camera quickly. Please don't waste our time. Please turn on your camera. Yes, very good. And now be ready with your book and pen. Before that, please adjust your camera so that I can see your face properly. Sit straight and your face must be visible, completely visible. Yes. Okay, very good, very good. Yeah, so we were dealing with before that. Is there anyone who is attending? Just a minute. Yes, sure. Yes, Anne. Is there anyone who is attending maths class for the first time? Anybody? If you are new to my class, can you please raise your hand? Yes. Who is that, ma'am?
Joshna.
Yes, Joshna, can you please unmute and please introduce yourself in 2 or 3 sentences? Hi, Joshna, please unmute.
Sorry, ma'am, can you repeat your question?
Can you please introduce yourself?
My name is Joshna and I'm from Kerala.
Okay. Yeah. Yes, Joshna, welcome to the class. I'm so happy to see you. Next one is?
Just a moment, ma'am.
Yeah.
Mariam.
Mariam. Yes. Hi, Mariam.
Hi, ma'am.
Please introduce yourself.
Yes, ma'am. I am Mariam and I am 14. I'm turning 15 this year.
Okay.
I'm new to 10th grade in this class, but I've been here in grade 9.
Yes, I remember you. Yeah. Okay, so how was your class 9th exam, especially maths?
Some questions were kind of confusing, but the
Okay.
rest was okay.
Overall, it was okay, right? Yes. Okay. Mariam, welcome to the class again. I'm so happy to see you again. Then next one is?
Abdul. I don't know how to pronounce it.
Yes, okay. So let's ask her. Hello.
My name is Sophia. Actually, in the name it's some error.
Okay, so what is your name? Okay, yeah. Yeah, welcome to the class. Yes, okay, welcome to the class. So happy to see you. What happened with your name and roll number? Can you change it? No, she can't. Okay, fine. Yes. So please do the needful. Then next one, please turn on your camera, Shahin, please. Shahin, can you hear me? Yes, very good, perfect. Please unmute and introduce yourself.
Yeah, ma'am. Hello?
Hello.
Can you hear me right?
Yes, you're audible.
Shahin, I live at UAE right now.
Yeah.
It's
Okay.
my first tuition.
Oh.
I've never went into stuff like that.
Oh, this is
I
your
failed in
first
maths last
experience.
year.
Okay. Yeah.
That's why my dad asked me to join this class.
Okay. So which is your favorite subject?
Science?
Science. What is your opinion about maths then? It's difficult.
Very bad. I don't know anything.
Okay. Nice. So let's see. What is your opinion after this class? First tuition.
Okay.
Yeah. Okay.
Yeah.
Yes, Shahin. Now one more person.
Joy.
Joy. Yes.
Hi, my name is Joy.
Okay.
I'm from Kerala.
Ah.
And I live in UAE right now.
Okay,
And
John.
this is my first class.
Yes. Welcome to the class, John. So happy to see you. Yes. Okay. Ma'am, can you please minimize that? Yeah, one person is there. Robin sir, can you please do the necessary things so that I can unmute him? Yeah, others, your camera must be on throughout the class. Okay, you are not supposed to turn off your cameras in between the session. Your face must be completely visible and you must be ready with your book and pen. Then you must take down notes, whatever necessary questions or important points, you have to write it down in your notebook. Yes? Okay. One second. Hmm. Yeah, and let me introduce myself. As you can see here, my name is Anila and I'm your maths teacher from 90 Plus Hyper Tuition. Some of you are finding maths difficult, okay? Anyways, so let's learn this together. Don't worry, this is an easy subject. We don't have to memorize so many things. It's like we have to remember one equation, and using that equation we can solve so many questions, right? We don't have to memorize things. Yeah, so this is easy. Don't worry, we can make it this easy together. We can learn this together. Robin sir. Today are we solving questions? Yes, Amelia, today we are going to solve some interesting questions, and we were dealing with real numbers. This was our first chapter, right? Real numbers. Okay, this was the first chapter, real numbers, right? Yeah, and we already covered some topics from this chapter. We already introduced LCM, HCF, and we discussed about rational numbers, irrational numbers, right? Okay, now let's start with a question today. We have the first question. One second. Find the HCF and LCM of 6, 72, 120 using prime factorization method. Okay, we have to find the LCM and HCF of 6, 72 and 120 using prime factorization method. If you want, you can do this together just like the 6, 72 and 120 like this together, or you can factorize the 6 alone, then 72, then 120, and then you can do accordingly. Today we have some new students, so let me solve this question for you. If you know this, you can do it yourself, okay? Otherwise, listen to me. Yeah, so here we have the first number as 6. Okay, 6 is the first number, and we have to check for the primes or the prime number which divides the 6 completely. So let's start with the smallest prime number, and the smallest prime number, yes, we can unmute someone and ask them which is the smallest prime number. Yes, Priyanka, right answer. Let's unmute someone and ask them.
Right hand.
Yes.
2.
2, very good. 2 is the smallest prime number, and this 2 divides 6 completely. So we can write it as 2 into 3, which is 6. Again, using 3, we get 1. Therefore, we can write the 6 as 2 into 3. Right? Alright, we can write the 6 as 2 into 3. Now, let's take the second number, which is 72. Okay, we need to factorize 72, and last class we discussed about divisibility, right? How to check whether the number is divisible by 2? We can look for the last digit. If the last digit is 0 or an even number, then it must be divisible by 2. So here, when we consider 72, the last digit is 2. So can we divide the 72 completely by 2? Yes, ma'am, can you please unmute someone? 72. Can we divide the 72 by 2?
Ananya.
Yes, Ananya.
Yes, ma'am.
Yes. And what is 72 divided by 2?
36.
36. Okay, very good. Now the next number, can you guess the next number? 36 by? Yes, please unmute her.
It can be divided by 3.
3. Can we divide it with 2? Because I'm checking with the smallest prime number possible. Then we can go with other numbers. Yes, can
It
we?
can be divided by 3.
Yes. And what is 36 divided by 2?
18.
18. Very good. Then next number?
2.
2. Okay. So we get?
We get 9.
9. Okay, then can we divide this 9 by 2?
No.
No. By 3. Yes. And we get?
3.
3. Very good. Again by 3 we get 1. Very good. Very good. So 72 is equal to 2 into 2 into 2 into 3 into 3. Right? Okay, so 2 is repeated 3 times, and LCM 2, 3. LCM 2, 3. No, HCF 2, 3 and LCM 360. LCM 2, 3. Why this 2 and 3? You mean 2 into 3? Okay, anyways, let's see. This is equal to 2 raised to 3 into 3 square. Right? We can express 72 as, yes, Fatima, right answer. 2 raised to 3 into 3 square. Then what about the last number 120? Who is ready to factorize 120? Who is ready to factorize 120? If you are ready, you can raise your hand. Okay, one second. Before that, Regin, you are also new to this class, right? Hi, Regin. Can you please unmute?
Hi, ma'am.
Hi, Regin. So this is your first class, right?
Yes, ma'am.
Okay, please introduce yourself.
My name is Rajan and I'm 15 years old
Okay.
and I now live in Dubai.
Dubai. Okay. Yes, Regin. Welcome to the class. So happy to see you.
Thank you, ma'am.
Yeah. Okay, and ma'am, please unmute someone. We have some hand raises. So,
Radhya.
Radhya. Yes, Radhya.
Yes, okay. So for 120, so 2,
2. Okay.
60.
60.
Then
Then,
again by 2,
yes.
we get 30.
30. Very good.
And then 2 again,
2 again.
15.
15.
So we do it with 3 now.
3. Okay.
And 5.
5.
And 5 we divide by 5 and 1.
Yes. Very good. Very good. Yeah. So this is equal to 2 into 2 into 2 into 3 into 5. That is equal to 2 cube into 3 into 5. Right? Yes. So this is how we factorize these three numbers. Now we have to find the HCF and LCM. Many of you have already learned this. I know this. But since we have some new students today, I am explaining this again. Okay. Yeah. So the next one is HCF. We have to find the HCF. For this, we have to look for the common factors. Okay. Here we have 2 and 3. Okay. Here we have 2 and 3. Here we have 2, 3 and 5. Okay, so we can't take this 5. 5 is not common. But here we have 2 and 3. Here also 2 and 3 is there. Here also we have 2 and 3. So we can take that common factors 2 and 3. Okay, 2 into 3 we can take and look for the least power. Okay, here the power of 2 is 1 and here it's 3 and here it's 3. We have to take the least power and it is 1. So it is 2 raised to 1 only. And in case of 3 also, we have to look for this least power. Here the highest power is 2. We don't want this highest power. We are finding HCF. So we have to look for the least power and it is 1. So 2 raised to 1 into 3 raised to 1. Simply 2 into 3 which is equal to 6 will be the HCF. Okay, 6 is the HCF. Yes, Rihan, right answer. Then Shwari, yes, right. Now we have to find the LCM. When we consider this LCM, we have to write all the factors which is present in the prime factorization of the given numbers. Which means we have to take this 2, 3, yes, 2, 3 and here we have 5. 5 is not common but we have to take all the factors which are present in the prime factorization. Whether it's a common or not, we don't consider this. We only consider, no, in HCF, we only consider the common factors, but here, HCF, okay, which means we have to take only the common factors. Okay, here we have 2 and 3. Here we have 2 and 3 in the prime factorization. Okay, here we have 2, 3 and 5. Okay, 2 and 3. 2 and 3. Here we have 2, 3 and 5. But we only take the common factors. Okay. Here we have 2 and 3. Yeah. Here also we have 2 and 3. Here also we have 2 and 3. But here we have 5. But 5 is not common. Here we don't have 5. 5 is not there. Here also 5 is not there. So in case of HCF, we only take the common factors. Okay, common factors. Here the common factors are 2 and 3. So we have to write that 2 and 3 first. 2 into 3. Okay, that is how we write the factors. Then we have to take the least power. Okay, we have to take the least power of this 2 and 3. Here the power of 2 is 1 and power of 3 is also 1. Okay, here power of 2 is 3. Okay, we don't want this 2 raised to 3 because we are looking for least power. Here the least power is, we have to consider all the 3 numbers and their prime factorization, and the least power here is 1, so it will be 2 raised to 1. Then here in case of 3 also the least power is 3, and we have to take it as 2 raised to 1 into 3 raised to 1. Okay, when it comes to the LCM, okay, LCM, we have to take all the numbers or all the prime factors which are present in the prime factorization of this given numbers. So here we have 2 and 3. Anyways, we have to write this 2 and 3. Here 2 and 3, we don't have to repeat that. Then we have one more factor, it's 5. Okay, we have 2, 3 and 5 in the prime factorization of these numbers. Now it's LCM. Okay, it's LCM. Now we are looking for the highest power which is present over here in the prime factorization. So when we look for this 2, power of 2, here it's 1, here it's 3, here it's 3. So the highest power of 2 present here is 3. So we have to take 2 raised to 3. Okay, then let's consider the second one, which is 3, and here it's 3 raised to 1, here it's 3 raised to 1, and here it's 3 raised to 2. So we have to look for the highest power possible. It is 3 raised to 2. Okay, but in case of 5, we just have 5 raised to 1 here. So the highest power, lowest power, whatever it is just 5 raised to 1 only. So 2 raised to 3 into 3 raised to 2 into 5, which means this is 2 into 2 into 2. We have to multiply 2 3 times, then multiply 3 2 times, and then multiply it with 5, and we get the LCM as, what is the LCM? LCM is equal to 360, 360, 360. Okay. Any other answers? Everybody got it as 360? Yes, very good. So the LCM is 360 and HCF is 6. Very good. Any doubts about this one? How to find the HCF and LCM? Anybody? If you have any doubts, you can raise your hand. Okay, before that, we have some new students. So if you are having any doubts in between the session, here Pooja ma'am is sitting here to help you. So you can send your messages to classroom, right? Sir? Classroom. So you can send your messages or your doubts to classroom in between the session, or if you are not getting the reply, or she may be busy or something like that, or if you want to ask me, you can just raise your hand, okay, and ask me. It's not like raising hand like this. There is an option, raise hand, okay, otherwise we may miss you. Okay, so raise your hands using that. Yes, Bhagat.
Ma'am, in this case, just to check if my answer is correct, I multiplied the 3 numbers and then I multiplied HCF into LCM. But I got different.
Yeah. Here comes this one. In case of 3 numbers, product of 3 numbers is not equal to the product of their HCF and LCM. Okay. Yes, Bhagat. Very good, very good, very good. So, we already learned one result in last class, right? Do you remember that result? Yeah, he already checked that one. Yes. So, in case of 2 numbers, we have 2 numbers and HCF of AB into LCM of AB. A and B are any 2 numbers. When we multiply their HCF and LCM, we will get their product. Okay, for example, we can consider this one. Okay, we already find the answer of this one. HCF and LCM of 6 and 20. Here HCF is 2. Okay, HCF is 2 and LCM is 60. So we get 2 into 60, which is HCF into LCM is also 2 into 60, that is 120. Right, HCF into LCM is 120, and when we multiply these 2 numbers, that is 6 and 20, we get 6 into 20 is equal to 120. So see, LCM into HCF is equal to the product of these 2 numbers. This was one result. HCF we take the lowest power, and for LCM we take the highest power, right? Yes, you are right. Yeah, so in case of 2 numbers, product of LCM into HCF is equal to the product of 2 numbers. Okay, that was one result that we have learned in the previous class. Okay, one second. This was the result. But when it comes to three numbers, here we just have two numbers, but when it comes to three numbers, product of three numbers is not equal to the product of their HCF and LCM. Here you can check that. Okay, take the product of numbers and take the LCM and HCF. Here the HCF and LCM are 6 and 360. When we multiply this, okay, one second. When we multiply this HCF and LCM, this is not equal to the product of these three numbers. Okay, or 6 into 360, that is the LCM and HCF. 6 into 360 is not equal to 6 into 72 into 120. So you can check that. In case of three numbers, the product of HCF and LCM is not equal to, it is not equal to the product of three numbers. Okay, that result is applicable only for two numbers. In case of three numbers, it doesn't satisfy the condition. So the product of three numbers is not equal to the product of their HCF and LCM. Okay? Yeah, so that result is applicable only for the two numbers. In case of the three numbers, we can't use that result. Okay. Yes, any doubts? Any doubts? Okay, fine. Now we
Yes,
have,
ma'am.
yes.
Devananda?
Yes, Devananda.
Yeah, ma'am, I had a doubt. If we need to find HCF, we take the lowest power, right?
If we take,
Like,
yes,
no,
always
yeah.
power. Yeah,
okay, and so the LCM, ma'am, it's the highest power.
yes,
right?
yes.
Okay.
Yeah.
Yeah, that's.
Yeah, okay. Yes, Evelyn.
Evelyn?
And in the last class you gave homework and that the first question, that is 26 and 91, I was not able to find the LCM.
26 and 91.
Yeah.
Okay, one second. 26 and 91. So how do we factorize this 26?
2
2,
and 13.
30. Okay. What about 91?
3 and 13.
Okay, 91 by 3. What is 91 by 3?
Sorry, ma'am.
91 is not completely divisible by 3. We can take 7. Right?
So yeah.
Yes.
Yeah, ma'am. I took 7.
Yeah, so 91 by 7 is
13.
30. Okay, so we can write this 91 as 13 into 7, right?
Yeah.
Yeah, so now HCF, we have to take the common factors, which is common, only 13 is common, so 13, and the highest power is 1, so it's 13.
Okay.
Yes, now what about LCM? We have to write all the factors, so it is 2 into 13 into 7, and their highest power is 2 raised to 1 into 13 raised to 1 into 7 raised to 1. So just multiply and you will get the answer.
Okay, ma'am. Thank you.
Yes. Okay.
And Haripriya?
Yes, Haripriya. Any doubts?
No, I want to answer.
This question.
Yeah,
Yeah. So 2 into 13 into 7 is equal to
182.
182. Yes, very good. So the LCM is 182 and HCF is 30. Yes. Okay, very good. Now we have the second question. Complete the following factor tree. Can you complete the following factor tree? Here we have an unknown value which is x. How to find HCF? Okay, one second. How to find HCF? We can take this example. Okay. What you have to do is look for the common factors. Okay, what is common? Here it is 2 and 13. Here it's 13 and 7. So see, here we have 13 and here also we have 13. Just write that 13 first. Okay, which is the common prime factor? Yeah, so we have to write that common factor. Common prime factor here is 13. So you have to write that 13 first. Okay. Now look for the lowest power of 13. Here it is 2 into 13 raised to 1 and here also it's 13 raised to 1 into 7. So just write that lowest power here. So it is 13 raised to 1. Okay, for example, let's take one more example, say this one. Okay, here it's 6 is 2 into 3. Okay, 6 is 2 into 3 and 20 is 2 raised to 2 into 5. Okay, we have to find the HCF. How do we find the HCF? So HCF is equal to, we have to look for the common factors. So here we have 2 and 3. Here we have 2 and 5. So what is common? 2 is common. Here and here we have 2. So just write that 2 first. Okay. Now look for the lowest power of this 2. Which is the lowest power? Here it's 2 raised to 1 and here it's 2 raised to 2. So the lowest power is 1. So it is 2 raised to 1. HCF is equal to 2 raised to 1. Okay, this is how we find the HCF. Is it clear? If it's clear, please give me a thumbs up. Shafia, is it clear? Okay. Yes, now we have this question, complete the following factor tree. So we have X and Y. Please do reply to that question. Yeah. So here we have, please pin her. Okay. So here we have two unknowns, X and Y, right? We have two unknowns and we have to find them to complete this factor tree. Yes, and?
Yes, ma'am. So 13 into 5 is 65.
Yeah, here,
So
yes.
we can write y is 65.
65, yes, that is 13 into 1 second. 13 into 5, which is equal to 65. So y is equal to 65. Very good. Then what about
then,
x?
For x, we need to do 195 into 3.
Yes.
Just give me a moment.
Yes.
495.
Okay, 195 into 3, which is 495. Okay. Yeah. So everybody got the same answer? 490, x is equal.
No. I'm wrong.
Okay.
Yes, I'm wrong.
Then, which is the correct answer?
Just see. It is 585.
Okay, are you sure?
Yes, I'm sure.
Yes, 585. So everybody got the same answer, 65 and 585. Any other answers? 485. Who is that? It's 195 into 3. We factorized some number as 3 into 195, which means we have a number over here, and when we divide that number by 3, we get 195. So we have to find the number which is written over here. Okay, which means we have to multiply this 3 and 195, right? Okay, this is how we make this factor tree, right? Suppose we have, for example, let's take, yeah, 1 second. Forget about this question. I am just explaining this factor tree. Suppose I have 12 here. Okay, and when I divide this 12 by 2, I get 6. So I can make a factor tree like this. 12, then its factors are 2 and 6. Then again I can factorize the 6 as 2 and 3. Okay, so here the unknown number is in place of this 12. So here this is 2 into 6 is equal to 12. Here also the same thing is happening. We have to multiply this 3 and 195 to get the number x. So what is x? Is it 485? Some are commenting it as 485 and some others are commenting it as 585. Which is the correct answer, guys? 485 or 585? 195 into 3. This is just simple multiplication. You guys are in class 10, so I don't have to teach you this multiplication, right? Yes, 585 is the correct answer. 195 into 3 is 585. And here we have y. Okay, we factorized some number as 5 and 13, which means 5 into 13 will be equal to this y. So what is the value of y? Y is equal to 13 into 5 and that is equal to 65, right? Yes, everybody got this answer, right? 65 and 585. Yeah. Any doubts? Anybody, any doubts? Okay, very good. Now let's solve the next question. Explain once again. Explain why 17 into 11 into 2 plus 17 into 11 into 5 is a composite number. So what is a composite number? Do you know what is a composite number? Yeah, who is ready to tell me the definition of a composite number? And some examples too. Yes.
Amelia?
Yes, Amelia. What is a composite number?
A composite number is a number that has factors other than 1 itself.
Yes. Okay. Any example?
Like 15, 5 into 3.
Yes, 5 into 3.
1.
Yes, very good, very good. So, what is a prime number then?
Amelia?
Yes.
A prime number is a number that has factors. The factors are only 1 in itself.
Yes, very good, very good, very good. So, what are prime numbers? Composite number is a number that can be formed by multiplying two smaller positive integers. To be precise, prime number is a number whose factors are that number itself and, okay, 1 and that number. Okay, in case of a prime number, the factors are that number itself and 1. But in case of a composite number, it has other factors.
Ma'am, can you show the last one?
Last slide, sure. Okay, in case of a composite number, it has got other factors. Okay, other than that number itself and 1, it has other factors. So here the question is, yeah, we can discuss that questions. Okay, so here the question is, explain why this is a composite number, which means this is a composite number means we will get a number here and that number is a composite number, which means it has factors other than 1 and that number itself. For example, here we have 15 and we can express this 15 as 5 into 3 because 3 and 5 are the factors of 15. And we have one theorem. Okay, we have one theorem. Let me show you that theorem. Okay, wait a second. Fundamental theorem of arithmetic. What is fundamental theorem of arithmetic? Every composite number, take any number means any composite number, it can be expressed as a product of primes, right? It can be expressed as a product of primes, any composite number. So here, suppose I can express it as a product of primes, then it is a composite number. That is the explanation using fundamental theorem of arithmetic. But here, this is not the product. Here we have a plus symbol. So if it is something into something, a prime number into a prime number into a prime number, then we can definitely say that it is a composite number. So we have to remove this plus from here. What we do is 17 into 11 into 2 plus 17 into 11 into 5. We have to prove that this is a composite number. And I have to remove this plus from here. I can't simply remove this plus and do it as 2 into 17. Yes, take out the common factors. Very good, Gauri. Yes, take out the common factors. So here we have 17. Okay, it's two sums. Okay, first one is 17 into 11 into 2 plus 17 into 11 into 5. So what are the, yes, take out the common factors, 17 and 11. Here we have 17, here also we have 17, okay, 17 is common. Then here we have 11 and here also we have 11. So 17 and 11 are common. We can take that 17 and 11 outside. Okay, now open the bracket. After taking the 17 and 11, what is remaining here in the first term? We have 2. So we have to write that 2 inside. Then after that, it's plus symbol. I have to put that plus symbol here. Then here we have 5. Okay, after taking 17 and 11, we have a 5 there in the second term, and in the first term we have 2. 17 into 11 into 2 plus 5 is 7. Okay, so we have expressed the number as a product of primes. 17 is a prime number, 11 is a prime number, and 7 is also a prime number. So we have expressed this number as the product of primes. Therefore, this is a composite number. Okay, this is the explanation. First of all, you have to take the common factors outside, then open the bracket and write the remaining terms. Then you will get something like this. If you can express it as the product of primes, then definitely it is a composite number. This is the definition that you have to write in your answer sheet. Okay, so any doubt?
Ma'am, John.
Yes, John.
John?
Any doubts?
Yeah. Why do we have to take the plus out again?
Plus out again. Where is this plus out? This is inside the bracket, right?
No. Why do we have to remove the plus from there?
Remove the plus because here read the statement. Every composite number can be expressed as the product of primes. Okay, if we can express any number as the product of primes, then it is a composite number. Here we have to express the given number as the product of primes, then only we can say that it is a composite number. We have to justify our answer, that's why. Okay, yes.
Yeah, okay.
Yes. Okay, any other doubts?
Yeah, Evelyn?
Yes.
Ma'am, isn't it already a prime numbers? Already they're given it like 17, 11 into 2.
But here we have plus in between them. If we can express it as the product of primes, yes, this is a composite number. But here it is not the product. Here in between we have a plus symbol, no?
Okay.
Yeah, that's why we are trying to remove that plus sign. Yes. From starting your... okay, you can just collect the link. Okay, just send a message to the number from which you are getting the link for the class. Okay, because it's not possible to explain from the beginning. And just follow that link. If you are finding any question difficult, I will explain. Okay, you can send a message, ma'am, this portion is difficult, I will explain it again. Yeah. Okay, yes. Now we have the second question, similar question. Explain why this is a composite number. Here we have a twist. After taking the common factors, some of you may be confused by this question, but you guys are very brilliant. So let's see. 3 into 5 into 7 plus 7. Again, here we have a plus sign. Okay, so we have to remove that plus sign. Otherwise, we can't justify our answer. If we can remove that sign and we can express it as the product of primes, then we are done. Okay, so let's see whether we can express this as the product of primes or not. What is the first step? We can unmute someone. Yes. Okay, very good. Who is that? Gauri, check again. Okay. Yeah, we can unmute some. Who is ready to answer this question? Anybody? If you are ready, you can raise your hand. Yes.
Khushi?
Kaushal, right? No,
Khushi.
Khushi. Okay. Yes, Khushi?
So we will take 7 is common.
Yes, 7 is common in both the terms. We can take that outside. Yes.
Yeah, so 3 into 5 plus 1.
Plus 1. Yes, very good, very good, very good. So don't
And
forget
then,
to put this
we-
plus 1. Yeah. This is?
And then and this will be 7 into 15. It would be 105.
Where is this plus
Yeah,
1?
so plus 1.
Yes.
Plus
Okay.
1, then 105. It will be 105 plus 1, that is 106.
Okay, this is 7 into 15 plus 1 is?
16.
16. Okay, what is our aim? We have to express this as the product of primes, right?
Yes.
Okay, then.
So it will be 7 into 2 to 8. Give me 1 second.
Yes. Can't.
So 7 multiplied by 2 raised to the power 4.
Yes, very good. 7 into 2 raised to 4. Why can't we just add 7 plus 4? 7 plus 7. 1 second. We have this BODMAS rule. Do you know this rule? BODMAS rule. Rihan. So first we have to do, okay, forget about this B and O. Division, multiplication, addition and subtraction. Okay, this is division first, then multiplication, then addition and then subtraction, right? So you have to multiply this first. 3 into 5 into 7. Then add 7 with that product. Right? So we can do that in first step. It's not possible to add the 7 and 7 because we have to follow this BODMAS rule. Okay, that is why we are doing it like this. So what we do is just take the common factor outside. Here it's 7 and 7. So just take that 7 outside. After taking that 7 outside, look for the remaining factors or remaining prime numbers which is present over there in the first term. It's 3 into 5. What about the second term? Is it 0? No, it's 1 because 1 into 7 is 7. Suppose we are writing a 0 here, it's completely wrong because 0 into 7 will be 0. Any number into 0 is 0. So we have a 1 over there. Don't forget to write that 1. Some of you may have written in your notebook it as 3 into 5 into 7 plus 7. So when we take the 7 outside, it is 3 into 5. Just 3 into 5. No, I can see such comments in the chat box. This one is completely wrong. Don't forget to write this plus 1. Plus 1 is there. Invisibly plus 1 is there. Okay. Yeah, so don't forget to write that plus 1. Here in the previous question it was okay because here after taking this common factors we have a 5 there. So it was easy. But here we don't have any number. We don't have any number means 1 is there. It's invisible. Sorry. Yeah, so we have to write that 1 also. Okay? I don't understand. Wait a second. Why do we add 1 to 3 into 5? Yes, let me explain from the beginning. So it's 3 into 5 into 7 plus 7, right? Okay. So what is actually the 7? It is 3 into 5 into 7 plus 1 into 7, right? I can write the 7 as 1 into 7 because any number into that, any number into 1 is that number itself. Okay, 1 into 1000 is 1000, 1 into 10,000 is 10,000, right? Okay, so I can write this 7 as 1 into 7. Yeah, now look for the common factors. Here I have 7, here also I have 7. So let us take that 7 outside as common. So 7. Then after taking the 7, what is remaining in the first term? Here we have 3 into 5 and in the second term we have 1. Okay, suppose we are not writing that 1 there. We are simply writing 7 into 3 into 5. When we open the bracket, we will get this, we won't get this number. It's just 3, 7 into 3 into 5. Where is this plus 7? It's missing. Okay, so when we open the bracket, whenever we simplify, okay, when we do it the other way, we have to get the same thing. Okay, here when we open the bracket, we will get, yes, 7 into 3 into 5 plus 7 into 1. Use the distributive law, you will get this. Okay, so we have to add a 1 along with this 3 into 5. 1 is there already. Okay, just 7 means after taking 7, we have a 1 left over there. Okay, is it clear now? How did we get 1? Okay, is it clear now? Still, if you are confused, you can raise your hand. I will explain this again. Okay?
Leora, is it clear?
Yeah. Okay, what about Abdul, then Abdul Khan, then one more person, Shafia, right? Is it clear? Yeah. Your name I just forgot.
Abdul.
No, that was wrongly written. Yeah, your name was? Okay. Yeah, is it clear now? Actually, your voice is breaking. Can you please comment? Yeah. Okay, then one more person was asking the same doubt, Shafia, right?
Yeah, Shafia.
Yes, Joanne, is it clear? Any doubts?
I wanted to ask why are we taking the one in the question we did before in the 17 into 11 into
Okay, here we have after taking, okay, I just write this 7 as 1 into 7 just to avoid confusion. You don't have to write that 1. but it's there. Here it's 5. Okay, 5 is there. After taking the common factors outside, here we have a 2 and here we have a 5. So you guys are not confused. We can write 2 plus 5. But here somewhere asking why we are adding a plus 1 there. So just to avoid confusion, I just put it as 1 into 7. No need of writing it as 1 into 7. Just 3 into 5 into 7 plus 7. So after taking the 7...
So when we, so if we have, so we need a number left after we take common factor.
Yes, after taking a common factor, there must be a number. If we don't have any number there, it is 1.
We take it as 1.
Yes.
Okay.
Yes.
Thank you.
Yeah. Yes, there is also 5 there. Where? Yeah, here it's 3 into 5. We took that 3 into 5. It is in the first term. First term is 3 into 5 into 7 and the second term is 7. Okay, in the first term, after taking the 7, we have 3 into 5 and in the second term, we have 1. Okay. Yeah, where is Shafia? Can you hear me? Your internet connection was unstable. Yes. Okay, Bhagat. Okay, thumbs up. Yeah. Okay, can we move to the next question? Okay. Find the greatest number which divides 285 and 1249, leaving remainders 9 and 7 respectively. So before solving this question, let me introduce you some terms. Okay? Yeah. Suppose we have a term greatest in a question. Okay, here it's a word problem, right? Suppose we have a term greatest in a word problem. Then another term maximum, then highest, then largest. Find the greatest number, find the maximum of these something, or find the highest number by which we can multiply or something like that. So we have any of the 4 terms in a word problem, you have to find HCF. Okay, if we have any such words in a word problem, greatest, maximum, highest, largest, okay, all the higher ones like greatest, maximum, highest, largest, we have to find HCF. Okay, highest common factor we have to find. Okay, after this we have some other terms like smallest, minimum, then lowest, least. What we have to find? Any guesses? Everything is small, minimum, then lowest, least. We have to, yes, Rajastri, very good. Right answer, region, yes. Devananda, then Hannah. Yes, we have to find LCM. Right, Haripriya. Yeah. So whenever we have such words, smallest, minimum, lowest, least, we have to find the LCM. And whenever we have these words, greatest, maximum, highest, largest, we have to find the HCF. Okay, this is the difference between the word problems. Like suppose we have a term greatest, find the greatest number, something like that. We have to find HCF. Greatest, maximum, highest, largest. Okay, all such terms. Then here, in case of LCM, smallest, minimum, lowest, least, all these things we have to find the LCM. Apart from this, we have some more words. Okay, in case of this LCM, we have some more words simultaneously. Okay, simultaneously. Then together. Then at the same time. Okay, same meaning. Similar meanings, right? Simultaneously, together, at the same time. Then we have to find LCM. Suppose a bell rang at, okay, I will show you some examples. Then you will be familiar with these terms. Okay, so simultaneously, together, at the same time, such words are coming in the word problem means we have to find LCM. Okay? Yeah, so now let's see this question. Read this question. Find the greatest number which divides 285, then 1249, leaving reminders 9 and 7 respectively. So here I have a term greatest. So what I have to find? Greatest means, yeah, we have to subtract, leave that part. What we have to find here, greatest means, yes, see this, greatest means we have to find the HCF. Okay, greatest. Yeah, so here Find the greatest number which divides 285, then 1249, leaving remainders 9 and 7 respectively. Okay, for example, suppose I have a number 7, okay, and I am dividing it with 2, okay, then I get 3 2s are 6, 1 is the remainder, okay, and if I am subtracting this remainder from 7, okay, I will get 6. Then that 6 is completely divisible by 2, right? Okay, I have a number 7 and I am dividing that number by another number 2 and I will get the remainder as 1. Okay, now I just subtracted that number from this 7. Okay, remainder, I just subtracted that remainder from 7. Now the resultant is divisible, completely divisible by this number 2. Okay, so here we have two numbers, 285 and 1249, leaving remainder 9 and 7 respectively. So suppose I subtract this remainders, 285 minus 9 and 1249 minus 7. Okay, first find this, 285 minus 9, then 1249 minus 7. And just tell me the answer. 285 minus 9. Okay, if you got the answer, please raise your hand and tell me. Yes. Who is that, ma'am? Here.
John.
Okay.
So 285 minus 9 will be 276.
Yes, 276. And the other one?
And 1249 minus 7 is going to be 1242.
Yes, very good, very good, very good. Yeah, so now read the question. Find the greatest number which divides these two numbers, leaving remainder 9 and 7 respectively. So suppose I subtract the remainder, then these two numbers are completely divisible by that number, right? For example, okay, we can take the 7 again. Okay, 7 by 2, we will get a remainder 1. When I subtract this remainder, this resultant number 6 is completely divisible by 2. Similarly, here this 276 and this 1242 will be completely divisible by this greatest number that we are looking for. Right? Yeah. And here it is greatest number and you guys already commented we need to find HCF. So HCF of these two numbers we have to find. HCF of 276 then 1242 will be the greatest number which divides 285, 1249 leaving remainder 9 and 7. Okay? Suppose the question was just like this. Find the greatest number which divides. Okay, for example, suppose the question was like this. Find the greatest number. Yeah, greatest number which divides two given numbers, say 72 and 60. Okay, then you just have to find this HCF of 72 and 60. Okay, you just have to find the HCF of 72 and 60. But here the question is find the greatest number which divides these two numbers, leaving remainder 9 and 7 respectively. So in such cases, what you have to do is just subtract the remainder from the given number. Okay, then find the HCF because it's greatest. Yeah, whenever we have such terms, greatest, then largest, we have to find the HCF. So find the HCF of this resulting numbers 276 and 1242. Yes, find the answer and just comment. How can we factorize this 276? Who is ready to factorize 276? Who is ready to factorize 276? Anybody? If you are ready, please raise your hand.
Regin?
Yes, Regin, 276.
Yeah, 276 can be divisible by 2, which
Yes.
is 138.
138, yes.
And then 138 can again be divisible by 2, which will be 69.
69, okay.
And 69 can be divisible by 3, which will be 23.
23, yeah, okay. Can we divide this 23 again?
Yes.
Okay, so is 23 a prime number?
Yes.
Yes. Okay. So 276 is equal to 2 into 2, which is 2 square into 3 into 23, right? Yeah, very good, Regin. Very good, very good. Now, who is ready to factorize the second number 1242? Who is ready to factorize this number?
Sridhya.
Yes, Sridhya.
Yeah,
2, okay.
2, 6, it would 6.
6,
2,
2,
and 1.
1. Yes. Then
3,
3. Yes.
2, 0, 7.
Yes, very good. Then
Was 3.
3. Yes. Because 7 plus 2 is 9. Sum of digits is divisible by 3. Yes, we can divide this number by 3.
6.
6.
9.
9. Okay. Yes, 69.
Again, with 3.
3. Okay.
23.
23. Okay. Can we divide this 23 again?
Can't do further. Like 23 will be.
Yes, 23 is a prime number, so we can't do further. So 1242 will be equal to 2 into 1, 2, 3. We have 3 threes. So it will be 3 raised to 3 into 23. Right? We can factorize or we can express this number as the product of primes like this. 2 into 3 cube into 23. Now here comes the HCF. How to find the HCF of these two numbers? So it's HCF, right? It's HCF. We look for the common factors. Here 2, 3, 23. Here also we have 2, 3 and 23. So we can write this 2, 3 and 23. Okay. Now we are done with the common factors. Now what we have to do after writing the common factors, what we have to do, look for the highest power or least power. This is HCF, so highest power or least power? Least power. Yes, least power. So here power of 2 here is 1 and here it's 2. So we have to take the least power of 2, it is 1. Now in case of 3, here it's 1 and here it's 3. So we have to take the least power of 3, which is 1. In case of 23, it's 23 raised to 1 and 23 raised to 1. So we can write it as 23 raised to 1 only. 2 into 3 into 23 and that is equal to, what is the HCF? Final answer. 138. Haripriya, Regin, yes. Right answer. Ritika, okay. 138 is the correct answer. So HCF is equal to 138. So we get the greatest number which divides 285, 1249, leaving remainder 9 and 7 respectively is 138. Okay. So whenever you have such questions and here a part like leaving remainder, something like that, first of all leave that remainder. Okay. Which means you have to subtract that remainder. Yeah. Then you will get two numbers and here look for this key term. Yeah, greatest. Greatest means we have to find the HCF. HCF of what? Not these two numbers. Here they are leaving remainder. So you have to subtract that remainder first and then find the HCF. Okay, and you will get the answer. Okay, any doubts here in this question? Any doubts? No. Okay, suppose the question was like this. Okay, find the greatest number which divides, greatest number, you don't have to write this, I'm just asking you. Okay, greatest number which divides, say 72 and 16. Just, the question is just like this. Greatest number which divides 72 and 16. What we have to find? What we have to find? Find the HCF of what? HCF of? Do we have to subtract something? No, HCF of what we have? Yes, 72 and 16. We have to find the HCF of 72 and 16 simply. Because here it's not written that leaving remainder so and so. Suppose, okay, here in case of this one, I have to find the HCF of 72 and 16. Suppose I have some extension for this question, just like 16 leaving remainder, okay, leaving remainder 2 and 3 respectively. 2 and, okay, it's not possible. Okay, forget about this question. It's just an example. Okay, just an example. Yeah, so leaving remainder 2 and 3. So what is the first step? HCF of 72 minus 2 and 16 minus 3. Yes, you have to do this first. 72 minus 2 and 16 minus 3. Then you have to find the HCF of the resulting numbers. Yes, very good. Yes, then HCF. Yeah, very good, very good. Yes, so it's clear, right? Any doubts about that question? Whenever you have such questions, do that first. If you have reminder, just try to ignore that reminder just by subtracting. Yeah? Okay. Now we have, okay, these were the terms. Greatest, maximum, highest means HCF. Okay, don't forget this. Then we have the other one, smallest, minimum, lowest, least. We have the LCM. Okay, now we have some other words. Simultaneously, together, at the same time. This is LCM. Okay, simultaneously, together, at the same time. Then it's LCM. Now I have a question. In a school, the duration of a period in junior section is 40 minutes and in senior section it's 1 hour. If the first bell for each section ring at 9 a.m., when will the two bells ring together again? When will the two bells ring together again? We have to find the LCM. Yes, here we have a word at the same time or together. Simultaneously, we have to find the LCM. Yeah, here we have when will the two bells ring together? Yes, ring together. So we have to find the LCM. Yes. But here it's 40 minutes and 1 hour. So I have to find the LCM of 40 and 1. Is it so? Yes. Okay, I can see the correct answers. Yes. Okay, who is that, ma'am? Roshni. Yes, Roshni?
Ma'am, you converted to 60 minutes.
Yes, very good. Convert that 1 hour to 60 minutes first. Very good, very good. So here this is ring together. Ring together means we have to find the LCM. Okay, so we are done with this one. Identifying LCM or HCF. Yeah, okay, LCM. Now we have 40 minutes and 1 hour. Okay, 1 hour. So the units are not same. We have to make this same, which means 1 hour is equal to 60 minutes. Okay, 1 hour is equal to 60 minutes. Now we have to find the LCM of 40 and 60. Okay, now we have to find the LCM of 40 and 60. Same as before. Okay, if we are done with this part, okay, identifying whether LCM or HCF, it's over. Okay, because we know how to find LCM and HCF. That part is very easy. The only thing is identify this one. Okay, ring together. Yeah, LCM. Then it's okay. That question is done. Yeah, now let's find the LCM of 40 and 60. Who is ready to factorize 40? Here, Haripriya. Yes, Haripriya.
Not 2.
2.
20.
20.
2.
2.
10.
10.
2.
2.
5.
5.
5.
Yes, okay. Very good. So 40 is equal to, we can write this 40 as 2 into 2 into 2 into 5 or simply 2 raised to 3 into 5. Okay, 2 raised to 3 into 5. Now we have to factorize 60. Who is ready to factorize 60?
Leora?
Yes.
Yes, ma'am.
Okay.
So, divided by 2 will give you 30.
30, okay.
And again by 2.
2, yes, Amelia, right answer. Yes, 15.
Then by 3.
3.
5.
5.
Then 5.
Yes, very good, very good. So we can write the 60 as 60 is equal to 2 into 2 into 3 into 5 or simply 2 raised to 2 into 3 into 5. See, we have to find the LCM of these two numbers. Okay, LCM. One second. LCM we have to find, and in case of LCM, it's not about common factors. We have to look for all the factors which is present in the factorization. Here we have 2 and 5. Okay, 2, 5, and here we have 3. We have to take all the prime factors. So 2, 5, and 3. Now we have to look for the least power or highest power of these numbers. Least or highest? Highest. Okay, highest. Yes. And here the highest power of 2 is 3. Here it's 2 and here it's 3. So it is 3 only. Then in case of 5, it's 5 raised to 1 and 5 raised to 1. So just simply 5 raised to 1. In case of 3, it is again 3 raised to 1. So 2 raised to 3 into 5 into 3. LCM is equal to 120. Okay, LCM is equal to, this is 8. 8 into 5 into 3. Okay, it's 120 minutes. But the question is different. When will the two bells ring together again? After 120 minutes means? Yeah, the LCM is 120. What is the final answer? Yeah, ma'am, let's unmute someone.
Path.
Yes, Parth.
Actually, I wanted to answer the LCM and all the 40 and 60.
Okay, yes, okay, Parth. Yeah. So they will ring together again after 120 minutes. 120 minutes, can you convert this 120 into hours? 120 minutes to hours? Yeah, 120 minutes is 2 hours. Very good, because we know that 1 hour, yes, 1 hour is equal to 60 minutes. Therefore, 120 minutes means 120 by 60, which is 2 hour. Okay, 120 by 60 is equal to 2 hour. Yes, so this is equal to 2 hours. LCM is 2 hours, which means they will ring together again after 2 hours, which means first they ring together at 9 a.m. Yeah, where is this 9 a.m.? Yes, here we have 9 a.m. They ring together at 9 a.m. They will ring together again after 2 hours, means 9 plus 2. Therefore, the answer is 11 a.m. Okay, 11 a.m. They will ring together again at 11 a.m. After 2 hours, right? After 120 minutes or after 2 hours means they will ring together again at 11 a.m. Okay, is it clear? Any doubts? They will ring together again at 11 a.m. Any doubts? Anybody, if you have any doubts, raise your hand. No. Okay, fine. Now I have a similar question. Should we write after 2 hours or 11 a.m.? We can write both. Okay, they will ring together again after 2 hours, that is at 11 a.m. Okay, because we don't want to lose any marks. Yeah, so we are writing it properly. Yes, we are not giving even a keyhole to lose our marks. Yes. Okay. Yeah. See, that takes 35 seconds to pack and label a box. You have to tell me. I'm not going to mark any keywords here. You have to tell me. Read the question and tell me. Yes, she takes, Sita, she takes 35 seconds to pack and label a box. For Ram, the same job takes 42 seconds, and for Geeta, it takes 28 seconds. If they all start using labeling machines at the same time, after how many seconds will they be using the labeled machines together? Yes, LCM, very good. So here we have labeled machines together. So we have to find the LCM. This is a homework question because this is very much similar to the previous question. Do this. In the next class, we can solve this. Okay? Yeah. So this is a homework question. Just take a screenshot or you can just write down this question in your notebook. See, that takes 35 seconds to pack and label a box. For Ram, the same job takes 42 seconds. For Geeta, yes, 35, 42 and 28. Yes. Geeta, it takes 28 seconds. If they all start using labeling machines at the same time, after how many seconds will they be using the labeled machines together? Yeah. So this is the question. This is a homework question. Do this, and when we come for the next class, we can discuss this one. Yes. Okay, now we have another question. Babu wants to organize. Okay. Okay, Shafia. Okay, wants to organize a birthday party of his daughter. He bought sweets. Show the previous question. Yes, sure. Okay, this is the homework question. Then this one. Babu wants to organize a birthday party of his daughter. He bought sweets of two types. One is laddu and the other one is jalebi. He had 36 laddu. You have some case study questions like this, right? Yeah, he had 36 laddu, 60 jalebi and decided to serve them. He wants to distribute the sweets among guests. All are his friends. We have a whole story here. But so he decided to distribute the sweets equally among them all. Maximum how many guests he can invite? Yes. Question, previous question. Okay, one second. I will show it. Yeah. Yes, we have to find the. How did you identify that? We have to find HCF. Why? Why? Because of the word maximum. Yes. Maximum how many guests he can invite? Yes, maximum. Here we have the word maximum and you can see this. Okay, one second. One second. Yeah, here we have whenever we have the word maximum, we have to find the HCF. Yes, and here we have the word maximum and we need to find the HCF. HCF of what? Here one is laddu and one is jalebi. Yes, we have a whole story here and we have only two numbers, 36 and 60. So the yes. So find the HCF of 36 and 60 and you are done with the question. 36 and 60. HCF of 36 and 60. Who is ready to factorize? Homework again. Yeah. This is the homework question. Yes, who is ready to factorize 36? Yeah, ma'am. Please unmute someone who haven't answered till now.
Hiya, Fatima.
Yes, okay. Yes, Hiya, 36.
36 by 2,
Yes.
and it will get 18.
18, okay.
18 by 2,
Yeah,
then we get 9,
okay.
and by 3,
Yes.
and
Yes, very good. So we can write this 36 as 2 raised to 2 into 3 raised to 2. Now the next person, 60. Factorization of 60.
Anne Marie.
Okay. 60 by 2.
30
30
by 2,
by 2.
15
Yes.
by 5,
Okay.
no, by 3, 5,
Yes.
5 and 1.
Yeah, okay, very good. And here if you want, you can write 3 and 1. Yes, so 60 is equal to 2 raised to 2 into 3 into 5. Now what is the HCF? Yeah, next one, what is the HCF of these two numbers, 36 and 60?
Roshni.
HCF is equal to 3. What? 3. What? Can you hear her? Like what? Your voice is not audible. Like some breaking. Voice is breaking. Yeah. Okay. Please do comment your answer. We can ask that to someone else. Okay.
Suhana.
Okay.
It's 2 and 3.
2 and 3. Yes. First we have to write 2 and 3 common. Yes. Then highest or lowest power.
Lowest.
Yeah. So which is the lowest power of 2?
1.
1.
2.
2. Yeah. And in case of 3?
1.
1. Okay. So 2 raised to 2 into 3 or 4 into 3. That is?
12.
12. Yes. So HCF is equal to 12. So maximum how many guests he can invite? It's 12. Okay. Yeah, everybody got this answer 12 or any doubts? Any doubts? If you don't have any doubts, please do lower your hand. Otherwise, you can raise your hand. Yes. Any doubts about this question? Maximum how many guests he can invite? 12 guests. Yes. Okay. Now we can discuss that homework question I gave you in the last class. These were the questions. So the first one, LCM is 182. And what about HCF? HCF is 30. Now just take the second one, 336 and 54. 336 and 54. Who is ready to tell me the answer? Quick. 336 and 54. If you are ready, you can just open your book. That was homework question, right? So just open your book and tell me the answer. Yeah, who is that, ma'am? Okay.
Hello? Hello?
Yes.
So you have to find the HCF is 6.
HCF is 6. Okay. LCM?
LCM is 3024.
Okay, so how do you factorize this 336?
336, 2.
2, okay.
168.
168, okay.
And then 2.
2.
Again.
Yeah.
And then it's 84.
84.
And then 2 again. It's 42.
42, okay.
Then 2 again. And there's 21.
21.
And there's 3.
3.
7.
7.
Then 7.
Yes, very good. What about 54?
2.
2.
And then 27.
27, okay.
Then 3.
3.
9.
9.
Then 3 again.
3, okay.
3.
3. Yes, very good. So 336 is equal to 1, 2, 3, 4. So 2 raised to 4 into 3 into 7. And this 54 is equal to 2 into 1, 2, 3. 3 raised to 3. So when we find HCF, we have to look for the common factors. It is 2 and 3. The least power of 2 is 1 and it's 3, so therefore it is 6. And when we consider LCM, we have to take all the factors 2, 3 and 7 and look for the highest. You can't see this. Okay, wait a second. Let me write this LCM here. So LCM is equal to 2 into 3 into 7. We have to take the highest power of 2, which is 4. Then highest power of 3 is 3 and 1. Yeah, so you will get the answer. Yes. Everybody got this answer, 6 and 3024? Everybody got this answer, right? Okay, now we have 3 numbers, 35, 42 and 28. Okay, so let me raise this. I am raising this. This was a homework question, right? Doubts? Any doubts about this question? This was homework. Everybody got this answer, right? Yeah, okay, now we have 35, 42 and 28. Yes, ma'am, please unmute someone.
Amna?
Yes, ma'am.
Yes, so 35 by?
35 can be divided by 5.
Okay.
And that gives us 7.
Okay.
And 42 can be divided by 2.
Yes.
And then that gives us 21.
Yes.
And then it can be divided by 3. It
Yes.
gives us 7.
Yeah. Then 28.
And then 28 can be divided by 2.
Yes.
It gives us 14.
Yeah.
And then 14 can be divided by 2.
Yes.
That is 7.
Yeah. So 2 square into 7. What about LCM and HCF?
The LCM is 420.
420 and HCF?
And the HCF is 7.
Yes. Okay. So everybody got this answer. Let me explain this once again. HCF, we have to look for the common factors. Here we have 5 and 7. Here we have 2, 3 and 7. Here we have 2 and 7. So only common factor is 7. So HCF is 7. Okay, here 2 and 3 is not there. Here 5 is not there. Here 3 and 5 is not there. So the only common factor here is 7. Okay, so HCF is 7. Now in case of LCM, we have to take all the numbers 2, 3, 5 and 7. Now the highest power of 2 is 2 square. Okay, 2. So the highest power is 2. So 2 square. Then in case of 3, it's 3 raised to 1. 5 is 5 raised to 1. 7 is 7 raised to 1. So, yes. Okay. Everybody got this answer right? Homework questions? Any doubts? One more question is there. Okay. Yeah. 9, 12 and 15. Yes. 9, 12 and 15. Who is ready to solve this 9, 12 and 15? Yes, ma'am.
Devananda.
Okay.
Yes, mom. So can I say for 9?
Yes.
Ma'am, 9 will be 3 and 3.
Yes.
12 will be 3 and 4.
3 and 4.
Yeah, it's
Is
like
4
that.
a prime number?
No, then 4 we can do 2 into 2.
Yeah, so it will be like this, right? 2 into
Yeah,
2 into
yeah,
2.
same
Yes.
thing.
Yes.
I got it like that.
Yeah. What about
And
15?
15 is 3 into 5.
Yes, very good. 3 into 5. So we can write this 9 as 3 square, then 12 as 2 square into 3, 15 as 3 into 5. What about HCF and LCM?
Ma'am, HCF is 3 and LCM is 180.
180. Okay. So in case of HCF, we have to look for the common factors. Here the only common thing is 3. So, and in case of LCM, we have to write all the factors. 3, 2 and 5. The highest power of 3 is 2. Highest power of 2 is 2 and 5 it's 1. So 3 square into 2 square into 5. It may be your network issue. Please try your network connection or try to rejoin. Okay. Yeah, everybody got this answer? 180, right? Yes. Okay. And don't forget to do today's homework question. Tomorrow or in the next class, I will ask you and you have to answer. Yes. So today's question, let me show that question once again. Your question is this one. See, that takes 35, then 42 and 28. And we have a keyword here together. Yeah. Any doubts about any questions? Sir. Sir. Okay. Any doubts? Yes, Amelia. Amelia, can you please unmute Amelia, ma'am? Hand raise.
That's not a hand raise.
No?
No, I actually forgot to put my hand down.
Okay, yes. So anybody, any doubts? Okay, fine. Now it's time for exam. As usual, you will get a link in the chat box. Just open that link, then enter your full name and your roll number. And ma'am, here a hand raise. Here, down. Down first. Yes.
Fahma.
Yes, Fahma.
Can you show the next slide of that question?
Next slide. Okay. This one?
Yeah.
Okay. Yes, sir. Please share the link. Okay, so you will get a link in the chat box. Just open the link, enter your full name and your roll number. It's multiple choice. Just select the correct answers and don't forget to submit. Okay, don't forget to click on the submit button. Yeah. So everybody must attend the test. It's simple questions related to the questions or the topics that we have discussed in today's class. Yes, ma'am. One more hand raise is there.
Rajashree.
Yes, Rajashree.
Ma'am, like before you told me, like there were rules, right, to check the divisibility. Like for 2, it's like the last digit must be 0 or divisible 2. So like, is there a for 7? Like
I'm not sure about the 7. Okay.
Okay.
There is no such thing. I think so. Yeah.
Okay, thank you, ma'am.
Yeah. Okay, so these are the questions. The least number that is divisible by all the numbers from 1 to 5. Least number that is divisible by all the numbers from 1 to 5. Okay, least number that is divisible by all the numbers from 1 to 5. Then the prime factorization of 96, you have 4 options, and here for the first question also you have 4 options: 70, 60, 80 and 90. Yeah, look for the keyword least number that is divisible by all the numbers from 1 to 5. Okay, then the second question, prime factorization of 96. 2 raised to 5 into 3, 2 raised to 6, 2 raised to 4 into 3, 2 raised to 4 into 3 raised to 2. Just factorize 96 and you will get the answer. Then third question. For any two positive integers a and b, HCF of AB into LCM of AB. Okay, for any two positive integers a and b, HCF of AB into LCM of AB is equal to largest number that divides 70 and 125, which leaves the remainders 5 and 8 is. Then the last question, 1 is a prime number, composite number, both prime and composite, neither prime nor composite. These are the 5 questions. Ma'am, is there any comments? Is there anybody submitted and got done? 10 out of 10. Very good, very good, very good. Okay. Who is that? 8. Okay, very good. Josh, Suraj. Okay. Then Joanne. Yeah. Ashwin. Okay. Submitted. Okay, very good. Done. Okay. Done. Okay. Yes. I got 58, no, 60 responses till now. 62. Okay. I want everybody to attend the test and submit. Don't forget to click on that submit button. Okay. So shall we discuss the questions? Is there anyone who is still attempting the exam? If you are still writing, please raise your hand. Otherwise, we can discuss these questions. Yeah, okay. Okay, okay. One question, yeah. Fine. So the questions was easy, right? Yeah. And now when we discuss these questions, you can just show me this answer using your hands, like 1, 2, 3 or 4. Okay, which option is correct? Yeah, so shall we discuss the questions? Okay, first one, the least number that is divisible by all the numbers from 1 to 5 is option number 2. So this is the least number. What we have to find? Least number means, just comment your answers. What we have to find? Least number. Whenever we have this least, we have to find? Yes. Okay, very good. Now we have the prime factorization of 96. Which is the correct option? Option number 1. Is that 1? Yeah, okay. So 2 raised to 5 into 3. Then third question, for any two positive integers, we have LCM of AB and HCF of AB. Their product is equal to option 1, A into B, right? LCM of AB into HCF of AB is equal to product of two numbers. The largest number that divides 70 and 125, which leaves the remainders 5 and 8. So here it is largest number, and so what we have to find? Okay, option number 3. Okay, yeah, largest number. So what we have to find? Could you please explain that? Okay. Yeah, so here the largest number which divides 70 and 125. Here we have some terms, largest, maximum, highest, something like that. Whenever we have such words, okay, one second, largest. Oh, one second, again. Yeah, largest means it's HCF. Okay, largest means HCF. So here we have the largest number which divides 70 and 125. Yes, leaving reminders. So here we have reminders. So first of all we have to eliminate that. For that we subtract 70 minus 5 and 125 minus 8. What is 70 minus 5? 65. 125 minus 8? 125 minus 8? 117. Okay. So we have to find the HCF of 65 and 170. 65 and 170. So how do we factorize 65? 65. Yeah, we have some hand raises, ma'am.
Haripriya?
Yes, Haripriya, 65.
Ma'am, I actually asked the last question, not this question.
Okay, can you is there anyone can you factorize the 65 now, Haripriya?
Yes, ma'am.
Okay.
5.
5, okay.
13.
13, okay. Can we factorize this 13 again?
No, ma'am.
No, okay. So 65 can be written as 13 into 5. What about 117?
3 square into 13.
3 square into 13. So what is the HCF?
13.
13, okay. Yeah. Now the last question, oneness.
Ma'am, I actually wanted you to explain the third question.
Third question. Oh, so you were asking about third question. Yeah, here we have a result. One second. HCF of two numbers into LCM of two numbers is equal to the product of two numbers.
Oh, okay. I thought I put 1 actually.
You thought it is co-prime numbers, maybe.
Oh.
Yeah, if it is co-prime, then what is the HCF? It's 1. But like one second. If we have two co-prime numbers, say 2 and 3, then their HCF is 1. Okay, so for any two co-prime integers a and b, their LCM is AB and HCF is 1 only. So again you will get the same answer. LCM will be equal to, here it's 2 into 3, which is 6. So for any numbers, whether it's co-prime or prime or whatever, their HCF into LCM will always be equal to the product of two numbers. Okay, here also, here it is 1 into 6. Yeah, that is equal to 2 into 3, which is 6. For any numbers, whether it's co-prime or whatever it is, their product is always, okay, product of those numbers will always be equal to, type the roll number wrong by mistake. Yeah, that's fine. Okay, yeah, and here we get the answer as AB. Okay, so LCM into HCF is equal to the product of two numbers A into B. Yes. And the last question, oneness, which is the correct option? Oneness, option number 4, right? Yes, it's not a prime number, it's not a composite number. Okay, 1 is a unique number, it's not prime, it's not composite. Yes, 1 is neither prime nor composite, because when we take the definition of prime numbers, that number has factors 1 and that number. Okay, 1 and that number. But in case of this 1, what about that number? It's 1 only, 1 and 1. So we can't say that it's a prime number, and in case of a composite number, there must be factors other than 1 and that number. Okay, factors other than 1, that number, then other factors. But in case of 1, we can't say that it's a prime or a composite number. It's neither prime nor composite. Okay, I wrote option 3 by mistake. No, it's not prime, it's not composite. Okay, neither prime nor composite. It's not a prime number, it's not a composite number, it's a unique number. Okay, one is a unique number. It's neither prime nor composite. Yeah. Any doubts about this question? Okay, Saeed. Yeah, fine, that's fine. Okay, anybody, any doubts? No. Yeah, so do you still think that maths is difficult? Somebody was saying maths is so difficult. I don't know, you don't like maths. So do you still hate maths, or is it somewhat okay? Yeah, fine. So see you all in the next class. Until then, take care. Bye bye. See you.